The next section that we're looking at here is actually taking some of these equations that we've been solving and trying to use them to solve some real life applications, trying to actually put them to use for something that makes sense in real life. I like to say that math does not live in a vacuum. We're not just here trying to solve equations just for the sake of solving equations. We actually want to take those numbers and make them mean something. We want them to mean something in real life. Here is a strategy. This is a very general strategy for solving word problems. I've sort of consolidated step 2 and 3 a lot of these problems that we're going to be solving. We can actually draw a picture. If not, hopefully we can go through and label the words in the problem and the items in the problem and try and make some sense of it. So what you're going to do first is read the problem carefully. I would just read the problem in its entirety once, and then I would come back and try and start to label things. Once you get a label or draw a picture, then you can write an equation based on that stuff that you've written down, the picture or the labels that you've written down. Then you can solve that. And finally, once you're done solving the equation, you hope to make sure that that solution makes sense. If you're talking about you're investing $1,000, you're probably not going to end up with $5 million. You're probably going to, you think that your answer needs to make sense in context. Before we actually go to look at a problem, we need to look at some key words here. You see in the left-hand column here, I have several different words, and on the right side, the operation that matches with them. So here, sum is always going to be a plus, a difference is a minus, a product is a multiply, and a quotient is a division problem. There are a couple more here that if you see the words more than in context, that can mean addition as well. 5 more than x would mean x plus 5. Less than in context can mean subtraction. So 5 less than x can mean x minus 5. Notice that I changed the order of those. With more than and less than, you need to change the order of the items. It's less important with more than because more than addition is commutative. You can change the order of addition and it doesn't matter. We saw that in the last couple lessons. With less than, it very much matters that you put them in the correct order. So 5 less than x, for example, translates to x minus 5. Let's try and translate this equation and solve it. So first, reading through the equation, the sum of a number and negative 11 is negative 15. We want to find the number. We don't know what the number is, so let's just call it x. That's the thing that we're used to using in math is x. The sum we said means plus if we look back up here at the chart. The sum of a number and negative 11 is, if you ever see the word is, that's typically where your equals sign goes, is negative 15. So the sum of these two items, the sum of x and negative 11, that would mean x plus negative 11, is negative 15. We have an equation. Let's see if we can solve it. What we can do is add a positive 11 to both sides and get x equals negative 4. That's our answer. Let's make sure that it makes sense in context. Does this number plus negative 11 equal negative 15? Is the sum of this number and negative 11 negative 15? It is, so that number does make sense. 40 less than 5 times a number is 52 less than the number. Remember, I said that subtraction is not commutative. It very much matters what order you write this. So 40 less than, we said that the less than can be minus. But the order changes when we talk about less than. 40 less than 5 times a number. 5 times a number is 52 less than again. There's that keyword less than again, the number. Remember with the less than keywords, we have to change the order here always. 40 less than 5 times a number is 52 less than the same number. Let's try and find the number. Solving this equation, we can subtract x from both sides. We could add 40 to both sides. And we could divide by 4. And let's see that our answer makes sense. 40 less than 5 times a number, so that's 40 less than 15. That's negative 25. Is that 52 less than the number? That seems to work out. You could check that in your calculator. It seems that we found the number. Take a second and try this one. I'm going to count to 3, and I'm going to open up my solution here so that you can see what I did. The sum of twice a number and 6. Here, I'll help you with the setup. The sum. It says twice the sum. So we're doubling not just the number, we're doubling the sum of a number and 6 is 2 more than 3 times the number. Let's see how that works out. Hopefully you got the same answer here. All right, another type of problem that you'll see is ones involving consecutive numbers. It could say consecutive numbers, consecutive even numbers, consecutive odd numbers. Consecutive numbers are back-to-back numbers. It's like 3, 4, 5, 6 are consecutive numbers, right? I've got some examples here. Some examples of consecutive numbers are 1, 2, 3, 4, 7, 8, 9. Regardless of which starting point you choose, when you start with a number, the next number up is that number plus 1, right? 2 is 1 plus 1. 3 is 1 plus 2. 4 is 1 plus 3. Depending on how many numbers we need, we can keep this going for as long as we needed or only keep the first several. Even if we start at a different endpoint, 7, the next number is 7 plus 1. The number after that, 7 plus 2. Then we would have 7 plus 3, 7 plus 4, and so on. If instead we had consecutive even or consecutive odd numbers, for example, I just picked a random starting point, 12. To get the next even number would be 14, 16, and 18. To get to the next even number, you go 2 up. 12 plus 2 is 14. 12 plus 4 makes 16. Plus 6 makes 18. So to get any consecutive even number, we're adding 2 to get to the next one. And again, we can keep as few or as many as we need. Odd numbers are going to work in very much the same way. To get to the next odd number, you always add 2. So I would have x plus 2, x plus 4, x plus 6, x plus 8, as many as I needed. Let's read the actual word problem that we're getting here. The sum of 2 consecutive odd integers. The sum, so the sum means we're adding 2 consecutive odd integers. Let's call them x and x plus 2. So if I had, for example, 3, the next number would be 3 plus 2 is 5. The sum of those numbers is negative 188. Let's find the two numbers. X plus x makes 2x. We could subtract this 2. We could divide by 2 and get negative 95. Let's see if that makes sense. If we want to find the numbers, we want to find both numbers. If this number is x, the next odd number, that number plus 2 would be negative 93. Do those two numbers add to negative 188? They do. And so we have found our consecutive numbers, consecutive odd integers here. Take a second and try this one. The sum of 2 consecutive even integers is 66. I'll help you with the setup. We have even integers x, x plus 2. If we add those numbers up, we should get 66. Here's what my solution looks like here. First I combine the x's, again subtracted the 2, divided by 2, and I got x equals 32. If my first number is 32, x, my next number, x plus 2, must be 34. And do 32 and 34 add to 66? Yes, they do. So then we found our consecutive even integers. All right, this one's a little tougher. 10 times the smallest of 3 consecutive integers. It doesn't say even or odd, it just says 3 consecutive integers. I'm going to label those here x, x plus 1, and x plus 2. Those are my 3 consecutive integers. 10 times the smallest. 10 times the smallest. 10 times x. This is going to be the smallest. X plus 1 has to be bigger than that. X plus 2 even bigger. Is 22 more than, so that's 22 plus 3 times, not just 3 times a number, but 3 times the sum of all of those numbers. So x plus x plus 1 plus x plus 2. Let me clean that up for you a little bit here. All right, the first thing I'm going to do is combine like terms inside that parentheses. X plus x plus x makes 3x. 1 plus 2 makes 3. And then we can distribute our 3 in. This 22 and 9 can combine, and also I could subtract 9x from both sides. 22 plus 9 is 31. So x equals 31. What are our three consecutive integers? X is 31. X plus 1 is 32. X plus 2 is 33. So those are our three numbers. Try this one out. You can pause the video if you need. I'm going to go ahead and erase and show you what my solution was. 5 times the smallest, that would be 5 times x, is 17 less than. Remember, with less than, we absolutely have to change the order. Less than means subtraction, but we have to change the order. Twice the sum. So not just twice a number, but twice the sum of those numbers. And I ended up finding x equals 11. And so then my three consecutive integers would be 11, 12, and 13. Here's an example of a problem that you probably could draw a picture to solve. A carpenter cuts a 6-foot board into 2 pieces. So immediately I know that I have a 6-foot board. 6 foot. He cuts it into 2 pieces. It doesn't say where he cuts it. He doesn't necessarily cut it into 2 equal pieces. In fact, it says one piece has to be 3 times as long as the other. So if one piece is x, the other is 3x. Find the length of each piece. Well, the good news is, based on my picture, the 3x plus x has to equal 6. Those 2 pieces have to add up to 6 because I only have one board split into 2 pieces. 3x plus x is 4x. And when I divide, I'm going to keep 1.5 here. I'm going to keep a decimal. This is a rare instance where I'm going to keep a decimal. If x equals 1.5, then my other piece here, 3x, 3 times 1.5, is 4.5. And so my 2 pieces are 1.5 feet and 4.5 feet. Do those add to 6? Yes, they do. Try this next example, very similar. Again, pause the video. I'm going to show you my answer in 3, 2, 1. A plumber cuts a 96-inch piece into 2 pieces. One is 5 times longer than the other piece, so I've got an x and a 5x. 5x plus x have to equal 96, and 5x plus x add to 6x. Dividing by the 6 on both sides, I get x equals 16. So if x is 16, then 5x, 5 times 16, would be 80. And do those 2 pieces add up to 96? Yes, they do. Those must be my pieces. In a recent Olympics, the United States won the greatest number of medals, followed by China. So the U.S. won the most, China won the second most. The U.S. won 16 more medals than China. So it seems like this whole problem, we're talking about the United States and China. And I'm just going to say, I'm going to label the United States as a U and the China as C. In the prior examples, we were using an X. There was not 2 distinct things. Here we have 2 things. We have the United States, we have China. Let's label them accordingly so that when we get to the end of this problem, we can easily figure out what's what. The United States won 16 more medals than China. So I'm going to label this one in this dark color here. The United States won 16 more medals than China. So the United States won some medals, not the same amount as China, but the same amount as China plus 16. They won 16 more than China. It says that together they brought home 192 medals. So United States plus China altogether equals 192. All right, this is the hardest type of problem that we've solved so far. We're going to have to, because we have 2 equations here, it's called a system of equations, we're going to have to either solve by substitution or elimination. The good news is we know what u is equal to here, and what we can do is we can sub that in for u here. C plus 16 is the same thing as u plus c equals 192. Notice all I did here was I took the u and I replaced it with what I know u is equal to. All right, c plus 16 plus c is 2c plus 16. subtract the 16. So then I'm going to come over here. I'm running out of space. 2c equals 192 minus 16 would be 176. Divide both sides by 2. And c must equal 88. 176 divided by 2 is 88. All right. It says how much did each country win? Right now I have solved for C, and I need to solve for U. I still don't know how many the United States won. The good news is, if I know what C is, I can come back over here and say the United States is that amount plus 16. So the United States must be 88 plus 16 is 104. I have solved for both now, and I could check. Together they brought home a total of 192. 104 plus 88, yeah, that makes sense. The United States is 16 more. 104 is 16 more than 88, so perfect. I think I have my two solutions here. The United States won 104, China won 88. Notice that since I labeled my variables U and C, there's not any ambiguity at the end over what is what, over which one means what. You know, you could use an X and a Y here, and it's fine, and you would end up finding a solution, but at the end you have to wade back through and figure out which one was your X and which is your Y. This is the last word problem here for this sample. Take a second and try and solve it. I've already labeled your variables. W for women and M for men, I think, is an appropriate choice. I'm going to erase my cover here in about 3 seconds and let you see how I'll work this problem. So since there are 40 students, I said the total of men and women must equal 40. There are 4 more women than men. So men plus 4 would equal the women. There are more women, right? 4 more, in fact. If this is what W is equal to, then I can take that and sub it into W. I could take this and sub it in for W, and that's exactly what I've done here. I've replaced W with M plus 4. Combining variables here, I get 2M plus 4. Subtract the 4, divide by the 2, and we get M equals 18. So the amount of men that we have is 18. Then we can take this value that we just got. We could sub it in anywhere that we want, but I specifically subbed it in here. So 18 plus W has to equal 40. Subtract the 18 from both sides, and you get W equals 22. There are 18 men and 22 women.